In this video, I'm going to show you how to calculate a probability in a new type of situation. In the situation that we'll be focusing on in this video, a person calculates a z-score, and then the person turns the z-score into a probability. So before we get into any examples, let's go into a little bit more detail about the situation that we'll be focusing on in this video. In the situation that we'll be focusing on in this video, there's a certain population that has a normal distribution or a bell-shaped curve. It could be any population of individuals. The mean and standard deviation of the population are known, and a single individual is being randomly selected from that population. In this situation, you can calculate any of these three things I have listed. You can calculate the probability that the selected individual will be below a certain z-score, above a certain z-score, or between two specific z-scores. Each of these three probabilities that can be calculated in this situation has its own set of steps that have to be followed. So if you want the probability that the selected individual will be below a certain z-score, you follow one set of steps. If you want the probability that the selected individual will be above a certain z-score, you need a different set of steps. And if you want the probability that the selected individual will fall between two specific z-scores, you need a third set of steps to get that answer. So these are the three, basically the three problems we'll be solving in this video. We'll be solving all three of these, and we'll go through at least one example of each of these three situations. And I wanted to make my examples in this video as realistic or as close to real life as possible. So I decided to make all of the examples involving IQ scores, because we know a lot about IQ scores in the general population. We know that IQ scores have a normal distribution or a bell-shaped curve, and we know that the mean is 100 and the standard deviation is 15. We know those two things. So since we know the mean, the standard deviation, and that it's a normal distribution, we can actually calculate all three of these in that real-life situation. So let's go over the steps for each of these three situations. Like I said, we'll be solving three types of problems in this video: a below problem, an above problem, and a between problem. These are the steps for the below problem. To get the probability that the randomly selected individual will be below a certain z-score, you calculate the z-score, then you look up the answer in the z-table. The answer is a decimal, and that's the probability that you're looking for. So it's a two-step process. If you want the probability that the randomly selected individual, well, I was about to tell you the steps for an above question, but before I do that, let's actually go through just maybe one example of a below problem before we move ahead. So here's our first example. So in the general population, IQ scores have a normal distribution and a mean of 100 and a standard deviation of 15. Like I said, this is a real-life example because these things are actually true about IQ scores. And we're imagining that a person is being randomly selected from that population, and we want to know what's the probability that that selected person will have an IQ below 97. Now notice the word below. That's telling you that it's a below problem. So we're going to solve this using that two-step process we just learned. Then we're going to turn that probability into a percentage, and we're going to find the percentage of the general population with an IQ below 97. So to get this percentage, what we're going to do is just take the probability that we solved for in part A and multiply it by 100, and that'll give us the percentage in part B. So let's imagine that in part A we find out that 46. Let's say we find out that the probability of getting a person below 97 is 0.46. Well, 0.46 times 100 is 46%, so the answer to part B would be 46%. Or let's imagine that the answer to part A comes out to 0.39. Well, then the answer to part B would be 39%. Because like I said, we're just going to multiply by 100 to go from part A to part B. These two answers go hand in hand. So our first step is to calculate the z-score. So remember, we know that this is true about the population. The mean IQ is 100, the standard deviation is 15, and it's a normal distribution. And we want the probability that a randomly selected individual from the population will have an IQ below 97. So what we do is we take the number that we're interested in, 97, we turn it into a z-score. So 97, remember, to get a z-score, you use a specific formula. You take the data value, subtract it by the mean, and divide by the standard deviation. That gives you a z-score. So what I'm doing is taking our IQ score, subtracting it by the mean of 100, and dividing it by the standard deviation of 15, and all three numbers are provided. So if you go up to the problem up here, you can see that all three numbers are provided. We have the mean and standard deviation up here, and in part A, we have the IQ that we're turning into a z-score, 97. So the number that you're turning into a z-score always goes right here. Then you always have your mean here and your standard deviation on the bottom. So 97 minus 100 is negative 3. Negative 3 divided by 15 is negative 0.20. In this type of situation, you have to leave 2 digits after the decimal point. So notice how I put negative 0.20 instead of just negative 0.2. That's because we have to have 2 numbers after the decimal point. We have to have 2 numbers after the decimal point so that we can use something called the z-table in part B. I'm sorry, in step 2. So we have our z-score. So in step 2, we're going to go to a z-table to look up our answer. So what we do is we break apart our z-score into a row and a column piece. So the row number is always the 2 digits that are right around the decimal point. So the 2 and the 0 with a point right in between. The column digit is always the final digit right at the end, which in this case is 0. So what we do is, when we go to our z-table, we go to row negative 0.2, that's right here, and we go to column 0, which is right here. This is the 0, and then we get our answer. We just go to where the row and column intersect, and the answer is 0.4207. That's the probability of randomly selecting a person from this population and getting a person with an IQ below 97. And like I said, if it's a below problem, it's a 2-step process, z-score and z-table. Now let's make a diagram to show what we just calculated. So here's the general population of IQ scores from the lowest person up to the highest person. And here is the population members who are below 97. And we just found out that the probability of getting a person in this red area is 0.4207. That came from the z-table, right? And if we take that answer and multiply it by 100, we get 42.07%, which tells us that 42.07% of the population has IQs in this area. So the probability and percentage go hand in hand. If 42.07% of people are in the red area, then the probability of getting a person from this area is the same number, but just written as a decimal, 0.4207. And then, so what I did here is I just shaded the area that we're focusing on, which is below 97. this is the probability of randomly selecting an individual from the red area. And then down here, we have our z-scores. So what I labeled here is 0 underneath the mean of 100, just to show that the mean of the population always has a z-score of 0. It's just kind of a reference point. And I marked off this z-score of negative 0.2, which is what we calculated. Actually, we turned 97 into the z-score of negative 0.2. We plugged this in, and this came out. So I just put both of them here to show that these two go hand in hand. They're at the same position under the curve. So yeah, we have the mean of 100, its z-score of 0, and the score of 97, and its z-score of negative 0.2. So we actually solved part A and part B, the probability and the percentage. Now let's talk about the above problem. So if you want to, if a person or an individual is being randomly selected from a normal distribution, and you want the probability that the individual will be above a certain z-score, you follow these 3 steps. You calculate the z-score, you look up the decimal in the z-table, like we did earlier, and then you go one step further. You subtract 1 by the decimal in the z-table. And I think that it'll make sense to you why we're doing this 3rd step once we go through our first example. So in this example right here, we have the same situation. We're talking about how in the general population, IQ scores have a normal distribution and a mean of 100 and a standard deviation of 15. And now we want to know, what's the probability of randomly selecting a person from the general population and getting a person with an IQ above 98? So notice how it's an above problem. And also, we're going to do a part B again and find out what percentage of the population is above 98. And just like before, we get this first answer and multiply by 100, and we get part B. So step 1 is calculate the z-score. So we take our IQ of 98, which we're focusing on in this problem, we plug it in, and we turn it into a z-score by subtracting by the mean, dividing by the standard deviation, which are provided here. 98 minus 100 is negative 2. 15 is on the bottom. Negative 2 divided by 15 is negative 0.13. And like I said, we have to leave 2 digits after the point so that we can use our z-table. So in step 2, we get our row and column. The row is negative 0.1, the column is 3, right here. And then this is where they meet up. This should actually say 0.03, but instead of 0.3, because the 3 is actually meant to be the 3rd digit. But I just forgot to put the extra 0 in here. So we go to where our row and column meet up, and it's 0.4483. But that's actually the probability below 98. It's not above 98. To get the probability above 98, which is what we're looking for, we do 1 minus the number from the z-table and get our answer. So 1 minus this equals our final answer right here. And now we're going to make our diagram. So now what we're actually focusing on is not the red area, but the white area right here. Because the white area is what we actually solved for. So what we found out is that the probability of randomly selecting an individual from the general population and getting a person above 98 in the white area is 0.5517. And if we multiply that by 100, we find out that 55.17% of the general population is in the white area. So we have our probability of getting a person from the white area and the percentage of people who are in the white area. Now, the number from the z-table, which was 0.4483, that is the red area. So the probability of getting a person from this red area below 98 is 0.4483. This is 0.4483 because the z-table always gives us the probability to the left of whatever number we're focusing on. And to get the opposite area to the right, you have to do 1 minus the z-table area. And I think that should make sense because if this is 0.4482, then 1 minus that would give you the opposite area because the two areas have to add up to 100, right? And 42, let's see, 44.83% plus 55.17% do add up to 100%, and they make up the entire curve. So the two areas are complementary. Down here, I labeled the mean of 100 and the IQ that we turned into a z-score, which is 98. And I labeled their two z-scores, 0, which is always the mean, and negative 0.13, which is the z-score that goes with 98 in our example. So we solved part A and part B once again. We got our probability following 3 steps. Then we did times 100, turned it to a percentage. Now let's solve the third type of problem, in which we want to know the probability of randomly selecting an individual between two z-scores. So we follow 3 different steps. We have to calculate 2 z-scores, look up both z-scores in the z-table, which gives us 2 answers. Then we subtract the larger answer by the smaller answer. So let's do an example of this. So we're in the same situation. A person is being randomly selected from the general population, and now we want to know the probability that the selected person will have an IQ between 97 and 105. So what we're going to do here is we're going to turn 97 into a z-score and also turn 105 into a z-score, and we'll get 2 z-scores. After that, we're going to look up both z-scores in the z-table and then get 2 answers. They'll both be decimals. Then we'll subtract the bigger decimal by the smaller decimal and get our final answer. And once again, we'll do times 100 to get our percentage. We'll find out the percentage of the general population between these 2 IQ scores. So, first, we calculate both z-scores. So here's 97, here's 105. So to get this z-score, you subtract 97 by the mean, divide by the standard deviation. To get this z-score, 105 minus the mean, divide by the standard deviation. It's just the z-score formula. We get these 2 z-scores. We look them both up, doing our row and column like we did before. Using our row number and our column number. And now we take our 2 answers and subtract the bigger one by the smaller one. Now it's important to remember that we're not subtracting the z-scores from step 1. We're not going to subtract 0.33 by negative 0.20. Instead, we're going to take the 2 numbers from the table, the 2 red numbers, and subtract them by each other. So it's the 2 numbers from the table that are being subtracted. And this gives us 0.2086. And if you get a negative answer, it means that you just reversed them. So make sure it's a positive answer. So that's it. The probability of getting a person between 97 and 105 is 0.2086. And the percentage of people between 97 and 105 in part B is just going to be this times 100, which is 20.86%. Like I said, you multiply by 100, turn it to a percentage. So now I want to show you what has happened here. So the z-table First we turned 97 into a z-score and we got negative 0.2. Then we looked up negative 0.2 and we got the area, or I mean the probability to the left, which was 0.4207 from the table. Then we turned 105 into a z-score, we got 0.33. When we looked it up, we got the area to the left of that, which was 0.6293. Remember that the z-table always gives you the probability to the left of whatever z-score you're looking at. Next, what we did was we subtracted the red piece from the green piece. We subtracted this piece from the bigger green piece, and we got what was left over. So basically, we subtracted the green by the red, and we got this area here that's left over, which happens to be 20.86% between 97 and 105 right here. So yeah, if you subtract a big piece by a smaller piece, you get whatever is left over. That's what's happening in this problem. So here's our answers.